In board games, have you guys noticed that there are two styles of games? There's competitive games and cooperative games, right? What is the difference between a competitive game and a cooperative game?
I got you.
All right, yeah.
In a competitive game, you're trying to beat your opponent. In a cooperative game, you're trying to beat the game.
Yeah. Okay. So it's kind of who your opponent is. That's a good way to put it. Okay, so cooperative, your opponent is the game. Let's work together, right? Opponent is game. And competitive ones are kind of zero sum. Have you heard the term zero sum before? Zero sum means if you take your score and you subtract your opponent's score, it kind of works out to zero. Why isn't it called a zero difference game instead of a zero sum game? Well, depends how you evaluate it. You could say they're the minimizer, so their score is negative and yours is positive, in which case it's a sum. I don't know, whoever coined the phrase got to pick it, so they picked that way. It's all how you look at it. But in a zero sum game, you're working against each other. If it's not zero sum game, then you're probably working together against a common cause. What is an example in real life of a zero sum game? Checkers. Chess, Go. These are all zero sum games. What about politics? Democrats versus Republicans. Is this zero sum or cooperative? We'd like to say they're all working together to make a better America, wouldn't we? I mean, it really should be cooperative, but in reality, when the Republicans get the presidency, the Democrats don't get the presidency, and vice versa. And so what probably should be a cooperative game has quickly become a competitive game. Have you noticed that? And how do you play a competitive game? Yeah, well, there's one way to play a competitive game, and it's called Minimax. And that's a interesting, you can look as far as you want in game theory. There's no better strategy than this. If the game is competitive, the answer is Minimax. Nothing is better than that. And if you're doing anything other than Minimax, you're playing an ineffective competitive game. Minimax is the answer. It's the ideal to competitive. And therefore, if Republicans versus Democrats is competitive, and it certainly is a lot of times, then they're going to play this way, and they do. And you can actually predict a lot of the dynamics in politics just by modeling both plot sides as playing a minimax strategy, and then you can predict what they're going to do, and you can use that to make all kinds of interesting predictions. And this is what game theory is all about. Anybody heard of game theory? Okay, well, I guess you could say we're going to talk a little bit about game theory. So, what is the best strategy in cooperative games? Here's the thing that's kind of cool about it. This is an open problem. So while we know the answer to competitive games, it's always Minimax. And we don't always know how to implement Minimax. We don't know the best way to evaluate it. We don't know exactly how to, there are open questions in competitive environments, but we know, at least at a high level, exactly what to do. In cooperative games, there are still enough open questions that there's not one strategy that's well established as being the one true answer. And so there's kind of an open area of intelligence here. And so that's kind of fun. So let's start by considering some very basic cooperative games. Actually, before I do that, I want to talk about why everything is competitive or cooperative. Have you ever heard of a game that's kind of partly competitive and partly cooperative? Munchkin? Yeah, that's true. You can help your opponents. But when you do in Munchkin, you're always doing it with the thought of, can I get more advantage than the other one? And when you do, when you play Munchkin, if you're playing with multiple people, it's a good idea to help your opponents, because if you raise you two up, the more cooperative situations you get in, the more you raise you and someone else up, relative to everyone else, that's improving your odds, right? So if I cooperate with you and then I cooperate with him, well then I'm the beneficiary, and you two, I get +2, you two get +1, and everybody else gets +0. That's helping me win the game, right? Right. So you can have all kinds of cooperative dynamics in zero-sum games, but in the end, what it comes down to is if you win the game, they don't win the game. And that's what makes the difference between a cooperative game and a competitive game, is if your winning means they don't win, then it's ultimately going to undermine everything else. You're only going to cooperate for one reason, and that's to gain advantage. Whereas if the game in the end says, hey, you can win with your objective and they can win with their objective too. You ever played Mafia?
Oh, yeah.
There's sort of a cooperative component there, but then again, you're sort of competitive too. I guess you have to ask the question of what is your individual goal? Is your individual goal to win at the cost of your opponent? Then it's competitive. Or is your goal to win for your own objective and they're going to win for their objective? Then there can be components of cooperation, and that's how a cooperative game works out. So if I were to ask on a test, what's the optimal thing in a competitive environment? It's minimax. What's the optimal strategy in a cooperative environment? It depends on the cooperative environment. Every environment is different. I guess you could say that the answer to both cases is maximize utility. It turns out that minimax maximizes utility in a cooperative, competitive environment. And in cooperative environments, it's not always clear what strategy maximizes utility because it depends very much on the game. So maximizing utility is always the answer, but what does that mean in a cooperative game? Well, it depends on the game. Let's start with the canonical classic cooperative game. Anybody heard of Prisoner's Dilemma? So here's the idea of the prisoner's dilemma. You and your buddy are, I don't know, spray painting buildings, or you're doing something bad, and you get caught, and the police take you into the downtown, and they take you into the back room, and they put you down at one of those tables, and they shine a bright light on you, and you know, all these things. But you're separated from your buddy. They will not allow you to talk to your buddy, and they say, looks like we got you. And they blow smoke in your face, you know, gotta make it exciting somehow. Whatever the police do to make you uncomfortable, and then they say to you, well, looked like your buddy squealed on you, you're in trouble, unless you want to cut a deal with us. And they slap some files down on the table. And here's the dilemma you're in. You have to decide, do you believe your buddy or do you believe the police? Do you squeal on your buddy, or do you say, you know, we're innocent, officer, we didn't do anything? Because the reality is the police don't have anything against, they don't have any hard evidence against you, and they know that if you don't squeal and your buddy doesn't squeal, you're going to get set free by the judge. So you have to decide, do you cooperate, which actually in Prisoner's Dilemma means cooperate with your buddy, not with the police, or do you betray your buddy? And if you betray your buddy, well, different things happen. And these are the utilities that they've associated with it. So if you stay silent, yeah, here's the deal. If you say, I didn't do nothing, I ain't saying nothing, go suck on a lemon, then, and if your buddy says the same thing, then you both get a slap on the hand and you walk away free. Now we've put a -1 here to say, hey, slap on the hand, but that's really a pretty good case, right? Well, the best deal for you, though, is you squeal on your buddy. If you betray your buddy, the police let you walk, right? This is you cutting a deal, but then your friend gets 5 to 10 in the slammer. That's a utility of -3. These numbers have been dumbed way down. I think that should be -3,000, but the -3 here represents your buddy gets betrayed by you, but he doesn't betray you. But then there's the risk. What if he betrays you and you betray him? So what makes this problem really interesting is if you do minimax, you always betray your buddies. And yet that's not really a great thing to do, because it turns out that if you always cooperate and your buddy always cooperates, if you're both totally loyal, you're going to take a less good utility than you could achieve. You're not going to ever get this 0. but you know what? Overall, you're just always going to get slaps on the hands. Whereas if you're the kind of people that stab each other in the back all the time, you're always going to get the really bad payoff. And so it turns out that cooperation can be a very positive thing when you do intelligent cooperation, and you have to work together on it. So we're going to do some analysis of how to make a good decision in this situation, and that's where we're going with cooperative games. But there's an introduction to it. Thanks for coming. We'll see you next time.